Welcome to my final project presentation for CSCI E90. My name is Saran Nong, and I am a software engineer working at the Harvard T.H. Chan School of Public Health. So let's get started. My motivation for this project has been my love for photography. Through the years, I have taken thousands of photographs, but haven't been able to organize them by things that are in the pictures. This gave me a great idea for my final project when I saw what AWS recognition could do. I wanted to build an application that would leverage recognition and be able to automatically label my images by facial attributes. This would allow me to do searches like find all my images that everyone has their eyes open and are smiling, or find me a photo of a girl around 5 years old who has a surprised look on her face. The goals of this project are to allow the user to upload images from an Angular front-end application to an S3 bucket, then use AWS recognition to get facial details about each person in the image, then to store this detail in a relational database. And last, to allow the user to be able to search the database by multiple different attributes and have the images displayed in the front-end application. Here is the list of technologies that we'll be using for this project. So AWS recognition, S3 bucket, relational database, Lambda, API gateway, and Angular frontend. Here we can see the architectural diagram for this application. So first you see the user will upload the image to the S3 bucket, and this will trigger a Lambda function that will send the image and bucket details to AWS recognition face details API, and it will extract the data from it. And another Lambda function will be called to write this to the database. The user will also be able to do a search query to the database, and it will return all the matching images from the search query. Let's dive a little deeper into AWS recognition. AWS recognition is a service provided by Amazon Web Services that offers powerful image and video analysis capabilities using deep learning algorithms. It allows developers to integrate advanced image and video analysis into their applications without needing deep expertise in machine learning. This is the list of some of the features provided by AWS recognition. Face liveness helps us to easily spot real people and stop fake attempts when checking for facial verification. Content moderation detects potential unsafe or inappropriate content in our images and videos. Labels detects objects, scenes, activities, landmarks, dominant colors, and image quality. Video segment detection detects key segments in videos such as black frames, start or end credits, slates, color bars, and shots. Text detection extracts skewed and distorted text from images and videos of street signs, social media posts, and product packaging. Celebrity recognition identifies well-known individuals to catalog photos and videos for media, marketing, and ads. And the main feature we will be focusing in today will be face detection and analysis, which detects faces appearing in images and videos and recognizes attributes such as open eyes, glasses, facial hair, and so on for each image. Facial detection is able to determine the presence, location, and scale of any faces present. Face comparison is able to determine if the face matches the face in another image. Facial attributes returns predictions for emotions, gender, age, and other parameters. This is the list of attributes we will be able to get from the Face Detail API, which includes age, range, gender, emotions such as happy, sad, angry, confused, disgusted, surprised, calm, fear, or just unknown. Also, if the person is wearing eyeglasses or sunglasses, has their eyes open or not, smiling or not, has a beard or mustache, has their mouth open, and so on. It also gives us a confidence level rating that tells us how certain any of these attributes are likely to be true. It also gives us a bounding box of where these attributes exist in the image. This will be a more comprehensive look into the demos of my application. So when we select upload file, okay, let's choose this one. So we will upload the image to an S3 bucket. And when it is finished uploading, it will trigger a Lambda function that will send the image details to the Face Details API from Recognition, and it will do a image analysis of the faces in the picture, and will write the results to the relational database. So when I press Get Image Details, it is querying the database for details on this particular image. So let's give it a try. So here's the details from this image. So we can see, okay, so the first person, we see a male who's around 31 to 39. He's happy. He's smiling. He has no eyeglasses or no sunglasses. He does have a beard and a mustache, so that's true. So it got that right, and his eyes are open, his mouth open. So perfect. It got the first person right. Then the second woman, about age 34 to 42, which seems about right. She's happy. She has a smile. No eyeglasses. No sunglasses. No beard or mustache. Eyes open. Mouth open. So that's also correct. So now we have the third person. A female baby between 0 and 4, and it says she has a surprised look on her face. So that looks about right. But where it gets it wrong is it says she's wearing eyeglasses, which obviously she's not. So yeah, recognition isn't perfect. It gets some things wrong. I've noticed it gets sometimes it can't tell when the eyes are open, and in this case it couldn't tell correctly that she's not wearing eyeglasses. But other than that, it got everything correct. It only detects humans, so it gives no details about this dog that's in the picture. Okay, and then the other part of the application is being able to query the database for these particular attributes that Recognition was able to determine. So let's give it a try. So let's look for a female who is happy. We do a search, and we get all these pictures of females who are happy. So the way I have it set right now is, as long as one person in the picture matches this criteria, it will return will return this image as the results. In the future, I would like to have it an option to be able to select if everybody's happy. That I didn't do yet. I only allow it to query one person. Okay, let's try another one. Let's look for a male who is calm and with a beard, and see if anything matches. Okay. It's harder to tell in these pictures, but you can see he has a calm expression. He has a calm expression. I don't think they have beards, but the pictures are really small, so I can't really tell exactly. Yeah, the beard one is not always correct either. How about happy with a beard? Yeah, you can see he has a beard. He has a beard. I guess it texts this as a beard also. So, but yeah, this is the front end application. Okay, next up, we will take a look at some of the other AWS surfaces that I use for this project. So this is our S3 bucket. You can see as you upload the image from the front end, it is stored in this S3 bucket. So one thing of note is the event notification. So this is what triggers the Lambda function. Whenever a new object is created, it will trigger this detect faces Lambda function that we will take a look at next. And this is our next service that we're going to take a look at. So this is our Lambda function. We can see here that the first thing it does is it will call this detect faces function, which uses recognition detect faces that we give it the image details, and it returns to us a response. So with these results, I organized the data in a way that I can process it a little bit better, separate all the attributes: gender, age range, smile, emotions, eyeglasses, sunglasses, beard, and so on. And then we will we will get the results, and we will pass it on to the next Lambda function, which will write to the database. And we will take a look at that also. So this Lambda function, we are using it to, we pass the information from the other Lambda function to this one it will create a table if it doesn't exist already with the correct attributes. And then we will do an insert into the table for each face that we find. We will add in detailed information for all of these details that we get from it. So this writes it to our SQL database, our relational database. So this is our EC2 instance where we will use to view our database. So we are logged in, and we're going to do a select star from image details to check out the database. So we can see here all the files that we have uploaded and all the details that we are saving about the gender, age, emotion. And we can see all the different emotions that we have. So I see we only have one surprise, but yeah, this is our database. Okay, and this is our other Lambda function that fetches data from the front end, or the front end will trigger this to fetch data from the database. So this will use the API gateway that we have here, that we have set up, and it will read the parameters from the input parameters from the GET request for where we will set gender equal to male or female, whatever we're looking for, and we'll read it into this Lambda function to query the database. Thank you very much for watching this long video all the way until the end. I really appreciate it. This was a very enjoyable project. I really feel like I learned a lot from it. Learned how to incorporate all the different services AWS has to get them to work properly together. It took a long time, but it was worth it, and I learned a lot. So thank you very much for watching to the end. Thank you.